Okay, so everyone, hello everyone. Actually, the thing is, as I have said, my fan is like quite weird. So, what I was saying, if you just like desaturate everything, can you guys see it? Can you guys see that I have desaturated everything? I think it's impossible to see, but I've actually desaturated everything. Like instantaneous desaturation. I think it might be seen, it might not be seen either. Okay. I really don't know what's happening, but yeah. Nonetheless, I need to actually fix the fan. Let's just do this HSV hexagon model. Okay, HSL double hexagon model. Okay, HSV and HSL are two different species. Do you understand? One is pure white and one is pure black. Okay, and also everything will be black in here. Everything will be black here, but this is a pure saturation. The middlemost part is the one that's doing its own thing, and lightness is whatever it's like. What is the difference between lightness and wait. Oh no. Okay. Hue, radiance, luminance, lightness. Brightness relative to the brightness of a similarly illuminated white. Wait. Visual perception of luminance. Okay. I really don't understand. Mm, what happens? Like, why do we? Lightness, by the definition of hue, is a relatively uncontroversial. It roughly satisfies the criteria and the colors of the same perceived hue. The definition of a lightness or value dimension is less obvious. There are several possibilities depending on the purpose and goals of implementation. There are four most common. The simplest definition is just the arithmetic mean. That is the average of the three components in the HSI model called intensity. This is simply the V. Let's talk about V. Hexagon model. Value is divided the largest component of a color. In the HSV hexagon model, value is defined as wait. Okay, this is fine. This is fine, I guess. Hexagon model value is defined as the largest component of a color. Our aim above. All the three pyramids, also all the secondary colors, cyan, yellow, magenta, and playing with white, forming a hexagonal pyramid out of the RGB cube. Okay, largest component of our color. Okay, I see. In the HSV model, basically value is the largest component of a color. Okay. Value is the largest component. And what is the HSL? The bihexagon model is where lightness is defined as the average of the lightest and the smallest color components. Lightness is defined as the average of the largest and the smallest color components. That is the mid-range of the RGB components. Mhm. I think to get the mid value, yeah, average can be a good like mid range. Mid range or mid extreme is a measure of central tendency of a sample defined as the arithmetic mean of the maximum minimum values of the dataset. Mid range. Okay. Mid range of the RGB components. Like for example, if R is 100 and G or B is like 50, then we will go do 100 plus 50 by 2. Okay, that's what it will be. HSV is basically the V is the maximum thing, and L is basically the mid range. Okay, so that basically is L is a bit more unintuitive. I really don't know what to say. I am actually quite confused now. Relevant alternative is to use Luma as a lightness dimension. Luma is the weighted average of the gamma corrected RGB based on their contribution to perceived lightness, long used as a monochromatic dimension in color television broadcast. We will actually keep a lot of things like this. Okay, sRGB, the R is REC 70709. What is REC 709? ITUR recommendation 709, primary is yield Y prime 709. Digital NTSC uses Y prime 601 according to ITU some recommendation 60 ITUR recommendation BD 601, and some other primaries are also in use which is different coefficients. Adobe RGB, this is the Adobe RGB Y prime 240. Y prime 709 is our HD TV. Y prime 2020 is our UHD TV or HDR. Okay, like we will this is a gamma corrected thing. Dang, this is just so like this is so complex actually. This is quite complicated. Luma is a lightness dimension, but how will we perceive Luma as? Like, how will it be? There are, we have three variables. For example, if I use hue, saturation, and Luma, okay. This is just so weird. Damn. This was one of the weirdest things I have ever seen. Hue and chroma. I don't know much about hue and chroma, but okay. Lightness. The simplest definition is to get take the arithmetic mean. That can be done. What our value does is that it takes the maximum of the R, G, and B. Like what is the maximum in here? Like at any point of time. Either way, the maximum is something like, for example, the value. For the value, the maximum will be, for example, if there is R equals to 100, B equals to 200, G equals to 254, and 254 will be taken as the value. It it will be a lot whiter basically. Okay, that will be a very much, like, what should I say, very much, let me just show this to you. Component average, this is what our HSI does. It takes the mean and it gets stuff like this. Max RGB, what is the max here? The max in between R, G and B. Luma might be one of the best alternatives for this. Hmm. Dang, that is just so weird. Wait. Hmm. Hmm. I really don't understand. If you just see, what is he see here? Hmm. Yes. While HSL, HSV and related spaces serve well enough to, for instance, choose a single color, they ignore much of the complexity of color appearance. Essentially, the trade-off perceptual relevance for computation speed. From a time of computing history, higher 1970s graphics workstations or mid 1990s computer desktops, sophisticated models would have been too computationally expensive. A simple transformations of RGB which preserves symmetries of the RGB cube related to human perception. So yes, that is RGB corners and equidistant on neutral axis and equally spaced around it. RGB gamma data more perceptually reinforced, such as CI lab, it becomes immediately clear that do not have the same brightness of chroma or evenly spaced hues. That's what I was thinking actually. Furthermore, different RGB displays use different primaries, so have different gamuts. Because HSL and HSV are different purely with reference to some RGB space. They are not absolute color spaces. To specify colors precisely requires reporting not only HSL or HSV values, but also the characteristics of the RGB space they are based on, including the gamma correction in use. Very good actually. Very well written. Okay, if we take an image and extract the hue, saturation, and lightness for a component, then compare this to the components of the same name as defined by the Hmm. As you can, color scientists, we can quickly see the difference perceptually. For example, examine the following images of a fire wither. The original is in sRGB color space. CIE level star is a CIE defined achromatic lightness quality dependent solely on the perceptual achromatic luminance Y, but not on the mixed chromatic components X or Z of the CIE XYZ color space, for which the sRGB color space itself is derived. I will explain that this appears similarly in perceptual lightness to the original color image. Luma is roughly similar, but differs somewhat at high chroma, but differs most of depending solely on a truly achromatic luminance and is influenced by the colorimetric chromaticity. I really don't know what this means, but HSL and HSV by contrast diverge substantially from perceptual lightness. Though none of the dimensions in these spaces match the perceptual analogs, the value of HSV and the saturation of HSL are particular offenders. In HSV, the blue primary and white are held to have the same value. Let me just let me just do this so that we don't get distracted by the colors. Are held to have the same value. Even the perceptually, the blue primary has somewhere around 10% of the luminance of white. Okay, the exact fraction depends upon the RGB primary in HSL. 100%, 100%, 90%, that is a very light yellow, is held to have the same saturation as a green primary, even though the former color has almost no chroma saturation by the conventional psychometric technicians. Such perversities led Cynthia Brewer, expert in color scheme choices for maps and information displays, to tell the American Statistical Association. Let me just computer science offers a few poorer cousins to these perceptual spaces that may also turn up your software interface. Turn up in your software interface such as HSV and HLS. They are easy mathematical transformations of RGB and they seem to be perceptual systems because they make use of the hue, lightness, value, saturation terminology. But take a close look, don't be fooled. Perceptual color dimensions are poorly described by the color specifications that are provided in these and some other systems. For example, saturation and lightness are confounded. So saturation scale may also contain a wide range of lightnesses. But it will progress from white to green, which is a combination of both lightness and saturation. Likewise, hue and lightness are confounded. So, for example, a saturated yellow and saturated blue is the same lightness, but a wide differences in perceived lightness. These flaws make the systems difficult to use to control the look of a color scheme in a systematic manner. If much tweaking is required to achieve the desired effect, the system offers little benefit over grappling with a few specifications in RGB or CMY. During the merge was for images, which is a confound perpetual color making attribute, so it's changing any relation. Resisting non-uniform changes to all three perceptual dimensions and distorts all the color relationship in the image. For instance, rotating a pure dark blue towards green will also reduce its perceived chroma and increases perceived lightness. But the same hue rotation will have the opposite impact on lightness and chroma. Hue is a circular quantity represented numerically with a discontinuity at 360 degrees. It is difficult to use in statistical computation or quantitative comparison. Analysis requires the use of circular statistics. আবার এখানে কি বলছে what they are talking about is that concludes that where users have to specify colors numerically. 12 formulations of HSB and HLS are flawed with respect to the properties of color vision. Now the can choose colors visually or choose colors related to other media such as Pantone, or use specific particular basis like LUV, CI 1976 color space or CI lab color space. Okay, HSB and HLS should be abandoned. Okay, I think they have said it quite aptly. RGB, HSL to RGB, HSL to RGB alternative. Okay. HSB to RGB. This is a very good representation of the HSB to RGB thing. HSI to RGB. Luma, Chroma, and Hue to RGB. LC, H star, C star, that. Oh. This one. Hue, Chroma, Luma. Okay. But seriously, minus 50 degrees. Do you see this? That is just so good actually. Like CI lab color space is just so good. I think we can use that. These can be translated to code pretty easily. But actually I don't understand what RGB cube is. Color theory is really weird, and we are actually talking about intuitive rising for our Linux desktop. So we actually need to be very meticulous. Okay, what will we do? I don't know what we will do, but yeah, that's it. That's it for today. We got to learn some new stuff. We actually did some new stuff. Let me just explain in meanwhile, because if I don't explain it, then it will be problematic. Let's just no. Okay. CD codes. Let's just explain it fast. Okay. Now at first, this is the global variables, these are the global variables, init and init, and this is the function call. And after the start control, what do? We actually call this function. Keeping it fixed, what allows us to define everything in a fixed manner. And init minus init is less than equals to 0. It's fine. Okay. It will just shift it to 24 hours. Okay, control helper. What is control helper? Control helper will be, and after that it goes to control helper. Control helper, what does control helper do? Actually calculates the percentage. It actually calculates the percentage, and what it does is that with a slight fall through, okay, P is greater than equals to 100. If P, for example, P is 205. If P is 205%, then we will let it to update. We will tell it to update actually to the next day, and then like into the next 24 hours. Okay. And then after it updates, the percentage, do you see this thing? The percentage is also returned. The percentage is again calculated and returned. And after that, when the percentage there with the new percentage, when the percentage is now less than 0, when the percentage is in negative, we will just print time to sleep, and then we will just return from that. The loop is going on. Where is it? The loop is going on in here, and console log progress. Otherwise, if it is not negative, then this is the case. Okay, this is what has happened. And this is the, at first it this actually this date means basically the day. For example, 1st January 2020. When the date is the get date is here, the variable is day, while the function to get the day is called get date. This is like, I don't exactly know, but this is very confusing actually. The get date, I don't know why they did it, but whatever. I am actually increasing the day through this and changing the percentage, and also basically this is just something like elapsed time, total time, the ratio, and in percentage in normal decimal form, the percentage is returned. Okay, yeah, so that's it for today.